So the fundamentals of forces have to do with Newton's three laws of motion. Um, so the first one states that an object in motion will stay in motion unless acted on by an external force. Um, so if we look at this one, number one, so if we have a ball rolling on a table, so if the ball is rolling along the table, you can imagine that at some point it might stop rolling. Um, so we have to kind of explain why this might happen. So if an object in motion will stay in motion, why does the ball stop moving? The answer is that there is a force on it that's making it stop moving, and that is the friction force. So um, if the ball is moving to the right, it stops because there's a friction force that's pushing it to the left, right? The friction with the table and the ball. So in space, that's why we have tethers for our astronauts, is because there's no real forces that will make an astronaut stop moving. So if it were to escape in space, he would keep floating that way forever because there are no forces. On Earth, we have air and friction and other forces that could stop an object in motion. So the point is that forces are the change in motion, are responsible for the change in motion. That's kind of the point of this first law. So in law number two, we have that the summation of all forces on an object is equal to its mass times acceleration. The way we denote this using equations is that the sigma, or the summation, of all forces equals mass times acceleration. So summation is the sigma, so it's the sum of all forces. And remembering back to kinematics, remember we separate everything into the x and y components. So for this, we can separate in the same way. Sigma fx equals ma in the x direction, and sigma fy equals may. So sigma, the sum of all the forces in the y direction equals m times the acceleration in the y direction. So for example, if we have a box or any object and it's pushed on one side with 10 newtons, and it's pushed in the opposite direction, 10 newtons, you can imagine that if this is the x direction, these two 10 Newton forces will cancel out. So we'll get 0 is equal to the sum of these forces, which is 0, is equal to mass times acceleration. And then solving for acceleration, we can see that the acceleration in the x direction will be 0. On the other hand, if I, in the y direction, have only one force, (20 newtons, let's say that's in the negative y direction, we can then solve in the y direction. Negative 20 would be the sum of all the forces in the y direction, and that would be equal to the mass times the acceleration in the y direction. So if we knew the mass of the box, we could then solve for the acceleration in the y direction, ay. And a lot of times we're going to see forces that are both in the x and y directions, with some angle relative to the horizontal or vertical. So remember that in this case, we're going to have to use trigonometry again to separate a force like this into its x and y components. See that a right triangle is formed because x and y act in perpendicular directions, and we can use trig to solve for those. And then we can use these two equations to solve for the accelerations due to that force in both the x and y direction. So that's going to be the strategy for all of these problems moving forward. The last law, number 3, says if object 1 applies a force on object 2, Object 2 applies an equal and opposite force on object 1. So remember, since forces are vectors, it has both a magnitude and a direction. So we can say words like opposite, which means we flip the direction. The equal part means that it has the same magnitude, so it has the same number. So if it's 10 newtons to the right, the equal and opposite is 10 newtons to the left. So for this example, if we have a box and a person, say the person pushes on the box 10 newtons. Okay, so this would be the diagram for the box. All the external forces on the box is 10 newtons to the right. However, if we were to draw the diagram for the person, we would know that he is pushed back on by the box 10 newtons. So therefore, the diagram for the person would be 10 newton to the left. So in this case, we're considering the system of the person, not the box. So these are two different systems, but only one action is applied. So you have to remember that all forces result in an equal and opposite force on the other object. Okay, and to just quickly talk about what a newton is, knowing that newton is mass times acceleration, we can know that newton can be written as the unit of mass, which is kilograms, times acceleration, which is meters per second squared. Okay, so newton is just the unit we can use for this form of units. And that's the unit we use to talk about forces.